What I have today, it's an introduction to GraphQL. We are going to be taking a look at the basics and fundamentals of GraphQL, what we need to understand to start building an API with GraphQL. And then we are going to jump onto a simple implementation of that API using Node.js. At the end, we will be able to deploy that API to Heroku and start doing our tests. What is GraphQL? GraphQL is a language specification that was created to pretty much interact with an API through queries. The same way we can interact with a database using queries, that's kind of the similar idea of how can we interact with an API, how can we tell an API that we want to get certain specific data by passing a query. So what is the main difference of GraphQL compared to, for example, a REST API? Is that with GraphQL, you are just exposing one API endpoint, instead of the REST approach that you are going to expose an endpoint per any specific entity in your application. Let's say for your users, for your projects, for the types of entities you are working in your project. So GraphQL just only expose one endpoint, and through that endpoint, you are going to get different queries that are going to interact with the data. Those queries are defined by a schema. So there is a specific file or a specific format that you are going to follow to define the contract of your API, to define the types or the objects you are going to use, and to specify the entry points of your API. GraphQL, it is an alternative to REST APIs and to SOAP web services. It was created by Facebook in 2012, and the main use case was to create an API technology for mobile applications. What was the problem is that with regular REST APIs, when you are serving data, you are sending all of the information or pretty much all of the properties of an object to the client that is requesting that data. So that is an expensive operation if you are doing it through a mobile application. Why? First, the more data, the more bandwidth. And second, the more data, the more CPU processing, and that's going to affect the battery life. So they needed to create a technology that allowed the client to request only the specific fields or properties that the client needs to do the rendering operation, to show the information on the screen. So that was the beginning of GraphQL. It is similar when you are running an SQL operation and you are just selecting certain specific columns from a table. GraphQL allowed to do the same by using a query, select the specific fields you need from the data that that query is returning, and get that data from the API call. So it was developed by Facebook internally in 2012, and they saw the opportunity to release this technology as open source, and now it was released to the public in 2015. Currently, there is a GraphQL Foundation, an open source foundation that manages and has all the governance of the project. So this project is just a specification. So it is already a standard maintained by a foundation. And in the specification, they don't impose the implementation. So you can find implementations in multiple languages. You can find GraphQL implementations for Java, for Ruby, for Python, for Go. So the technology here is not going to be any limitation. GraphQL is going to be just the standard. Today, we are going to be using JavaScript, or most specifically Node.js, to create a GraphQL server, but the same concepts apply to the other different languages. So if you are using Ruby, the same concepts are going to apply if you are going to try to create an implementation GraphQL implementation in Ruby. So let's start with the basics of GraphQL, and it is the schema definition and the types we are going to use. So first, let's take a look at the two different types of types we can create on GraphQL. Ones are going to be the scalar types, and the other are going to be the custom types. Scalar types are used for the specific properties of an object, and we can define these properties using the different types as integer. It's assigned 32-bit integer, or a float. We can also specify a string, a Boolean. There is a special scalar that is the ID, and this is used to represent an unique identifier. It's going to map to the same ID, for example, on a database that it's related to the primary key, for example. And certain GraphQL implementations uses these types of ID for cache management. And you can also find on the different package repositories, like NPM in the case of Node.js, different custom scalars that people have created in the community that can also be used on a GraphQL schema. Some of those can be the date scalar, for example, or the JSON scalar to specify that a specific property is going to be of a specific type. Then we can specify the object types. Here we are using the GraphQL SDL, the language that it's being used to specify the schemas, to create two different custom types or object types. In this case, we are going to create an application that it's going to let me manage different meetups. For example, for the Heroku Japanese user group, we want to have an application where we can have a list of all of the different meetups, the name of the meetup, the description, the members that attended to this meetup, and have like a counter with the total of people that attended the specific meetup. And we have other type to specify the member. So if you can see the way we are constructing these types, we use the type keyword, the name of the object using the uppercase as the first letter, and then we define the property. So name, in the case of the meetup, is going to be it's going to be a string, and that exclamation point at the end represents in GraphQL, the name is going to be required. So if you are using that exclamation point, it means that that property is required. If you see members, for example, members, it is enclosed in brackets. That means that members return a list of the object member. So we are expecting a list of members in that specific property. And again, I am using the two exclamation points to say that that list needs to be a list and that the members cannot be null. So they need to have real members inside. And for the member, I just need one property, let's say the name. On a more real application, we might want to have the email and other different properties. So this is letting me define the objects or the entities that I'm going to be using on my API. Then we need to define or specify the operations I can do on my API. And those operations are going to be either queries or mutations. A query, it's a read-only operation that is going to be used to retrieve data from my API. And a mutation, it's an operation that has a side effect. A mutation in this case are going to be special queries used to mutate data, to change data in our implementation. In this case, for example, to create a meetup or to create a member, for example, or to do an update or delete operation to the API. For that, we are going to be using mutations. So let's see how can we define the different queries in my application. So again, we are using the GraphQL SDL, the language used to create a schema. And we are specifying operations inside a special type, which is the query. The query type contains all of the different operations I can do with my API. So here I have a query called Meetups that receives an input parameter, which is the name of type string, and returns the information before the colon represents the return type of my operation. So this Meetups method returns a list of meetups. So I'm just defining the contract of my API. I'm just defining the operation. I am not defining the implementation yet. The implementation is going to come later. So here I'm just designing my API and defining the contract. And we have a similar approach for the mutations. So we have this special object, which is the mutation, or this special type. And here we define an operation the same way as we did with the queries. So we define a method or an operation with the different input parameters, and then we specify the return value. Here we have a different special type for GraphQL, and it is the input type. The input type, it's used on the mutations to specify complex objects that are going to be passed to the operation. So a mutation doesn't support a custom object to be used as an input parameter. So you will need to have an input object to be able to work with the different mutations. So this is something that is specified at the GraphQL specification. Up to this point, we already designed our API. Our API contains two types of objects, and those objects have a specific relationship. And we specified an operation or two different operations, one to retrieve the meetups and the other one to add a new meetup, but we haven't implemented those operations yet. So GraphQL doesn't specify the data source. The data source is whatever you want to use for your API. So it can be a PostgreSQL database, for example. You can have a database as the data source of your application. You can have a different API. For example, you can, when implementing those operations, go to a third-party API, fetch the data and return it. You can use local data, reading files, for example, or use those files as the data source for GraphQL. So in this case, GraphQL is just a way to map operations through a query to a function in the language you are using. In this case, it's going to be JavaScript. So in the next section, we are going to start talking about the resolvers. The resolvers are the operations that are going to be mapping to the operations we defined in the schema. So this is going to be the one-to-one map between the schema and the implementation, so we can start adding the logic to my API. Here, I am creating the query resolvers for the meetups in JavaScript. So I am creating a basic JavaScript object that contains the query name as a property. So here we are mapping to the query, to the special type query. Then we are implementing meetups. So this needs to have the same name we use in the schema. And this is a function that receives 4 arguments. So the first argument in this case represents itself. So usually you are going to ignore it. In this case, we ignore that argument. The second argument contains the input parameters of that operation. In this case, for the meetups, remember that we were passing the name. I'm going back to show you the query. So meetups had an input argument, which is name. And here I'm getting from arguments that input parameter. And then after I get that data, I'm going to return the operation. In this example, I'm fetching the operation from a database. So getting all of the meetups by that specific name. But you might want to do the API call or connect to a local file or serve this information from a different data source. But that's the way how you map the query specifying the file and the operation in the language. And for the mutation, it is the same. You need to map under the mutation type. Then you have the function, and the function has the same arguments. It's going to have the first argument represents itself. The second argument represents the input arguments of that function. And I forgot to mention the other two. The other two arguments are going to be the context, which is an object that is created on every request and can be used for attaching objects to the request scope or for doing authentication, for example. And the other argument is going to be info, and info contains the abstract syntax tree of the query if you want to do some query introspection. But this is more into the advanced part of GraphQL that I mentioned that if you are interested, we can have a second session about GraphQL best practice in productions, how to take care of security in GraphQL, how to optimize GraphQL operations. So we can continue these on a different meetup. So here we have the example of the mutation. We are implementing the add member function. And again, I'm extracting the different arguments from the input parameters. And then I am doing the operation on the database, creating the implementation in the resolver. So what we have seen is that to have a GraphQL server, you will need to have two things. One is the types definitions on a schema, and the second is going to be the resolvers, which is the operations that maps to that type definition. Now that we have those two things, we need to compile and serve those two things into a web server. So let's see how can we run a GraphQL server using Node.js. For that purpose, we are going to use Apollo Server. Apollo Server is a GraphQL implementation using JavaScript that are going to allow you to read a GraphQL schema and compile that GraphQL schema with a resolver definition object, and then create a server so you can start interacting with your API. So how can we build that server using Node.js? First, we need to install the Apollo Server library, and then we require both the Apollo Server class and the GQL tag. The GQL tag is going to be used to compile the schema language into the abstract syntax tree that I mentioned before. We specify the type definitions object, which is the compiled schema. Then we implement the resolvers, which is going to be the JavaScript implementation of that specific contract. And at the end, we create a server that has both the type definitions and the resolvers. We start the server in a specific port, and then we can start enjoying our GraphQL API. So let's do some live coding and create a GraphQL API from scratch using Node.js, deploy that to Heroku at the end. I'm not going to be connecting these to a database. I can show you a working example later if you want of a different project. I'm going to start from scratch, just serving local data. but then showing you how can you connect it to a database on a different project that is already running on production. Let's go to the terminal and let's create a new project. This is going to be GraphQL intro with Node.js. So this is an empty folder. I'm going to start a Node.js project using npm init. So I created a basic npm project right now. And remember that I told you that I need the Apollo server library to be able to create a server, a GraphQL server using Node.js. So I am installing Apollo server right now on my computer, and then I can start building up my project. So let me open Visual Studio Code and start building up the server. Perfect. So we need a server.js file. And then let's create a schema GraphQL file as well, because that's where we are going to have our schema definition. So let's start with the schema definition first. So we need, let's do the same example we did at the talk, at the presentation. So let's work with the meetups. So let's create a new type, which is meetup, that has a name, a description, and a list of members. And then we need the type member, okay? So we have the two types. Then we need to specify the query. So the query, it's going to be meetups, or let's call it, yeah, meetups, it's good. Meetups with an input parameter optional, which is a string, and it returns a list of meetups. Perfect. Now we have the basic schema definition for a GraphQL API. Let's create the resolver. So I'm going to create a new JavaScript file here, resolver. Let's change the name to resolvers. It's better. Okay, resolvers. Here in resolvers, I'm going to create this resolvers object that I'm going to export at the end, because I might need to require this file from the server. And then we need to map the query. So remember that we have a query called meetups that has arguments, context, and info. And here I'm going to return the list of meetups. So let me have an object with those meetups. So I have one meetup, Heroku Japan user group. Let's add another meetup, Tampa Bay SFDC. So let's say that we have two meetups. In this case, the data needs to be shaped in the same form of the data that we have on the schema. Right now, we don't have members. So let's add members as empty. And then we can come up with a list of members so we can return that data from the API. So now the implementation is going to be just return that data. So here it can be, as I said, a database operation, an HTTP request to a third-party API, or just returning local data. Last, let's create the server. We have the schema, we have the resolver, we need a server. So let's import both Apollo server and GQL from Apollo server. Nice. We need the file system module, and I will need the path module as well, because we are going to be reading the contents of the schema GraphQL file so we can compile it. So let's load the schema, read file sync, and that file lives in this directory, and it's called schema GraphQL. And let's load it on UTF-8 format. And then the type definitions, it's the result of the compiler, which is the GQL, over that schema file. And then we need the resolvers, which is a module we created. So now we have the schema, the type definitions, and then we need to create a server, pass the type definitions, pass the resolvers, and I'm going to enable another property here, which is the playground. The playground, it's something that Apollo uses so you can run the GraphQL API and you have a console to test that API. So you have a web console, so you can pass queries, you can introspect queries and take a look, everything is working. This is recommended for development, but not necessarily for production unless you have a public API. If you have used GitHub, GitHub has one of the biggest public GraphQL APIs out there. They have a GraphQL Explorer where you can pretty much interact with their API from the browser. And it's a very nice experience to be able to come up with the queries you need before you start implementing those in code. So Playground is the technology that allows us to do this using Apollo. And the other one that is available on other platforms, it's called GraphQL, which is the graphic interface for GraphQL. So after we create the server, then we need to listen into a port. Let's the 8000. And then let me capture the URL. And print that URL so we can access it. So this is my implementation, a GraphQL server in 15 lines of code, well, with a couple of other files, you know. And let's see if it works. This is live coding, so it might fail. Let's hope not. So I'm going to start that file running the Node server, and I got a function. Because path is not a function, and I did a typo, see? Errors that can happen live. Now, okay, now this seems to be working. I have a server running. Let's click on that. And now I have a GraphQL playground. So this is the interface I was telling you before. So one of the nice things about this interface is that it has this schema tab. Let me get this a little bit bigger. it has this schema tab at the right where you can take a look at the schema definition. So this is very useful because serves as documentation for your API. It lets the developer know the available types and the available operations. So I know that there is a query called Meetups that I can execute here on the query playground. So let's go execute that query. I'm going to execute the query Meetups. And then from Meetups, I need the name and the members. So here is where I am specifying exactly the type of information I need. Then I execute run, and it fails because it is asking me the members needs to have information, and I don't have information here. So let me filter from members. I need the name, and now I get the data. So I get the list of meetups. Remember that we created 2 with the members, and the members were an empty object. If I go ahead and modify the code and add people here, let's create a members list. I'm going to create here Satoshi Nagano, and I'm going to create myself. And let's add me on Heroku Japan. Why not? I want to go to Japan one day and visit you all in person. If I execute again this query, now you can see that Heroku Japan returns both Satoshi and Julian, but Tampa Bay is empty. And I can update my query to say, I just need the name of the meetups. I don't need the members. And now I am getting the information. So this is what made GraphQL very powerful and popular, because you are just requesting the data you need, and that's going to be for mobile applications way more performant because you are not spending as much data transfer. So it is going to be less bandwidth, less processing. So battery life is going to be better, and also improve experiences for front-end APIs. So front-end operations are going to be way less expensive because they just request the data they need to render the information on the screen, instead of getting a full JSON object that needs to be processed on the front end. So this was the example running locally. Let's modify this application so we can get it into Heroku. So what do we need to do? First, remember that if we want to deploy this to Heroku, we need to have it in a Git repository. So I created a Git repository running Git init. Then I'm going to update the package JSON to create a start script that tells Node.js, and it's going to tell Heroku what JavaScript file is going to execute on a start. You can do this, or you can create a proc file. It's going to work either way. Cool. I have those 2 parts. Third, remember that when you are deploying to Heroku, the port needs to be set up using an environment variable. So in Node.js, I can get that port using process.env port, or run on port 8000. So let's change that variable so we can run on Heroku. Perfect. Now everything seems that it's good to go. Let's create a new Heroku application. So GraphQL intro node. Let me prefix my name to guarantee that no other has created that. Okay. Let's confirm that the remote is good. I created the application. The remote it's good. Now I can add my files. Let's say this is the initial commit, and do a git push Heroku main. And this is going to push my code into Heroku, run the application, and it will let us start doing requests. I think since we are using the playground might have a security restriction. So let me see if I will need to enable a different property. Yes, we need to enable a different property because it doesn't let us do some things for due to a security restriction right now. Yeah, I don't think I can execute the query. Oh yeah, I can execute the query, but I can't do introspection. So that it's easily fixed by adding introspection true. So with introspection true, now it will allow us to do the debugging on Heroku. Enable introspection, git push Heroku main. And let's wait until it compiles. So see, as you can see, we were able to create a GraphQL API, deploy that GraphQL API to Heroku, and we did it all using Node.js on not a lot of lines of code. So Satoshi, that was my presentation. So thank you very much for having me here today. And remember, if you want to keep learning about GraphQL and Node.js, I have more content that I will love to share with you. Let me, before we finish, I promised that I was going to show you another project just quickly. I just want to show you the database part and to see the similarities. So this is a project that allow you to have like a list of properties to sell or to rent and manage leads and track customers that are interested into any specific property. So it has a little bit more complex schema. And if you can see on the resolvers, every resolver is attached to a database operation. So I'm doing a database operation to find all of the properties, doing a where. So the data source can come from wherever you like. So pretty much that's what I wanted to show you. You can return just a single value or execute a full database operation in a resolver. So that's very powerful in GraphQL. And I think that's it, Satoshi.